Yo, looking at 8.5, where we're looking more at these trig function identities in terms of the reciprocals here. And we're also looking at the Pythagorean theorem to solve for any unknowns. So you can use either one of these. I'd choose to use this one. It's a little bit simpler. And this one here, because you might be forced to use fractions or ratios with it. We're also going to be looking at the quadrant here, and you're going to be given certain cosine or secant, or you're going to be given sine and cosecant, and those values will determine which quadrant it's in. So it's a little bit of a review there. So in this first problem, you're given a placement on the unit circle, and we're given that the values are 6 and 8. So we can look at this as cosine is 6 or x is 6, or my sine is 8. So that means we need to find the radius length. And in order to do that, we're using the Pythagorean theorem. And here we go. We have that here. And then we're just using those and reducing it. So sine, just like we looked up here, we're looking at these ratios. So sine is y over r. And I'm simply putting y over r and reducing and getting 4/5. That's it. And then its reciprocal is cosecant. So we could see we just simply flip those. So the only work you're doing is finding out the missing variable. All of these are just putting those ratios and simplifying if you can. More of the same with the next one. Here we see we have an x value that is negative. We still have the follow through with the radius. We still get 10, and we're still using those same ratios. So y over r, 8 over 10 reduces, and we continue that. Same process for this next one, except this one has a 0 in it. So where is 0? 3. Here it is. And then we need to find the radius in the same fashion. And this is the first time that we're going to have to deal with having it undefined, because tangent is y over x. Our x value is 0, and we cannot divide by 0. This next one, I know that a lot of students get the heebie-jeebies when confronted with a negative degree. And so if we look at this, negative just simply means the direction at which we're going around the unit circle. So you see in black here, I'm going counterclockwise. That's what we're used to. 0 degrees, 90 degrees, 180 degrees, 270, and then 360. But if we start at the same place and then go around clockwise, here we see in red, then we're going down. This is negative 90 degrees. So 270 and negative 90 have the same value here, 0, negative 1. Come up here. Negative 180 and positive 180 have the same locations, where we have our x value is negative 1, our y value is 0, or cosine and sine. And we continue that. So if you need to change it to positive so that makes more sense to you, simply add 360 until you get a value in between 0 and 360. So I add 360 to this, it makes it 180. So the cosine of negative 180 and the cosine of positive 180 is the same location. And that is, what is the x value? It is negative 1. So that's where that comes from. Secant, all right, so this is the inverse of cosine. And so we're looking here, so it's negative 360. That scares me. So I add 360 to it and I get 0. Oh, very refreshing. So I'm looking at that on the unit circle, and so I'm looking at the values of 1 and 0. Since I'm dealing with secant, that is the inverse of cosine, so I'm still just looking at x. So that's 1 over 1, which is 1. And then here we're just simply looking at the inverses. So what is the inverse of cosine and secant? I just simply write out the inverse here. So 2/3 would be 3/3, negative 3/7 would be negative 7/3, and so on and so forth. Here we need to do some rationalization. So when we do put 1 over root 13, we can't leave it like that. That is rude and ugly. So we rationalize it, and we simply multiply by root 13, and here's what we get. You'll be seeing this a lot more during the rest of this chapter. I know a lot of students having issues with this, and so I'm dealing with sine. When is sine or the y value negative? This happens in quadrants 3 and 4, and then I look at the next factor, which is dealing with cosecant, which is also y. When is that also negative? This happens in 3 and 4. So both of these were concerning the y value. They both are negative in both of these quadrants. Sine, when is the y negative? This happens at 3 and 4. Cosine is the x value. When is this positive? Not there. There we go. And so that's how we kind of eliminate our options. Cosine, x over r. When is this negative? This is happening in 2 and 3 quadrants. Sine, when is that positive? Not here. There we go, quadrant 2. So we continue this process. And if you need to draw it out, do what you need to do. So cosecant is dealing with sine or y value, r over y. So when is this negative? It is negative in 3 and 4. And then the other part is looking for secant, which is inverse of cosine or x value, r over x. So when is x positive? That is here. And in this last one, dealing with sine, when is it positive? 1 and 2. Secant is cosine or x. When is that negative? In 2. Done. So in this next one, the thing that's different from the first 4 problems is that we're given a quadrant that it's in. So we just can't disregard this information. It gives us this information so that we know when our x or y is positive or negative. So in quadrant 2, I have a negative x value and a positive y value. So when we look at this ratio, I can go, oh, okay, I know that tangent is y over x. I know that my y is positive, therefore my x must be negative. And so these are things that sometimes if you just disregard it, you can end up getting 4 out of the 6 things incorrect. Even though you go over here, you do the work, you find out, oh, my radius is 5, but you leave out the fact that one of your values is negative. And so just like above, we just simply put this sign as y over r, 4 over 5, and we continue that process for the rest of them. And then the last one, it's the same process, except we have a radical. Ooh, very scary. We're in quadrant 1, so that is positive, positive, so I don't need to worry about negatives here. On here, I have sine value, which is y over r. So my y is root 3, my r is 7. I need to find out what my x value is. So here is the setup. Here's where students fall off the tracks. They just says, since all of the other problems had everything on the left-hand side, we just can't disregard it, all right? So we have a y value that is root 3. That is what we're squaring. We are looking for the x value. Our r is 7. So we need to make sure we set it up correctly. When we solve, we get root 46. We cannot simplify that. So you might have a radical that can be simplified. So you need to be able to simplify that. For example, if you had root 40, all right, so we can simplify that into root 4 times root 10, which is 2 times root 10. That would be what you would use, and so you'd be able to simplify. Typically, during this part of the problem, is simplification is the issue that students have with not finding these ratios. So here, root 46 over 7, very good. Here, we have cosecant, all right, and so this is where we have 7 over root 3. We can't leave it like that, so we have to rationalize. Same thing here with secant. I have 7 over root 46. We need to rationalize. And in tangent and cotangent, we start with y over x, which is root 3 over root 46. I multiply here. You might end up with a case at which you can simplify this. I can't in my case, so I'm done. And same with the last one. So you might have cases where you can simplify these numbers here. Do that. If you're allowed to be simplifying further, do it.